This is Allison Buttenheim at the University of Pennsylvania. This is Module 5 in our Experimental Studies week on the nuts and bolts and logistics of actually running an experimental design study. Learning objectives, we're going to focus on the blinding process and the potentials for bias that arise in experimental designs, and also talk about some other important features of the operations of an experimental design, including compliance tracking, endpoint selection, and endpoint ascertainment. So how do we come up with our study population? This is a little different from what the processes we've discussed for case control and cohort studies. Here, we start with the source population, and that's usually identified by the type of study we're doing, the exposure and the outcome we're interested in, the sampling frame that we have available, and then we need to screen for eligibility. We're going to have eligibility criteria in our study that will make some people eligible and some not, and you see those ineligible folks popping out right there. Among those who are eligible, they need to be willing to be randomized to a study, and there's lots of interesting work done by Penn researchers on people's willingness to be in a randomized study and how much they need to know about the study and how much they need to be incentivized to join a randomized controlled trial. And there will be people who will decline participation. Often, people want to know ahead of time that they're going to get the treatment and not get the control, and of course, they can't participate if that's the case, because we have to be able to randomly allocate. So we may lose people at that point. It's nice if we can get some baseline data or ascertain other outcomes about those folks to see how different they are. Obviously, we want to generalize from our study results to a larger population, and if we've lost a particular type of person here, we need to know about that. So if we can gather a lot of data before you proceed to randomization and eligibility, you'll have some of those data available. If they're willing to be randomized and they consent, then they're in the study. And at that point, we do treatment allocation, and we talked about that in the last module, about how that's actually accomplished. Some folks will end up in the treatment group, some folks will end up in the comparison group, and then we do the intervention, whatever it is, a device, a procedure, a drug, participation in a program, and we see what the outcomes are, good versus bad, for the two different groups. That's a very simplified version, but that's basically how it looks. Here's an example from the Hypertension Detection and Follow-up Program, the HDFP. They started with a very large sampling frame of eligible population of about 178,000, and of those, 19,000 were not willing to participate in the study. So about 158,000 completed the first screening, and at that point 135,000 were ineligible. So from this huge sampling frame, we're already down to only about 23,000 who are eligible. At that point, another 5,000 were unwilling to participate in the study. So that left about 17,000 for the second screening, and we still found ineligibles, and that left finally a study population of about 11,000 willing and eligible participants. And these percentages you see are all percentages of the original 178,000 baseline. So you can see how quickly what even seems like an enormous sampling frame can get whittled down to a more manageable number of participants. All right, I want to talk about blinding. We talk about controls being blinded or double blinded, and all that means is that we're hiding the treatment assignment from hopefully both trial participants and investigators. Blinding is very common in clinical epidemiology trials. It's very uncommon in community trials, and if you think about it, it's pretty hard to accomplish that. If someone's participating in a program, they pretty much know it, and they know if the study was supposed to have an online version versus an in-person version, they'd get that they're on the in-person version. Similarly, if we're putting devices into people, the surgeon's going to know whether they're putting pacemaker A or pacemaker B into a patient. That's very hard to hide. Some trials, though, it is easier to blind it. Either the participants or the investigative staff don't know which group they're in. And we've talked a lot about bias, and we'll talk about bias some more, but you can see the advantages for blinding, particularly for people who are ascertaining exposure and or outcomes. It's better off if they don't know the treatment status of the person they're evaluating. And double blinding is particularly great. It just takes a lot of specific forms of bias off the table. So hard to accomplish, but worth it. And some of the advantages we've talked about, there's going to be no systematic differences in the treatment of the participants by the observers based on expectations for outcomes. Challenges may include feasibility, ethical challenges, consent problems, and the establishment of rules for breaking the blind, and that goes to stoppage rules that we discussed before. Often people want to know afterwards, if they've done a blind trial, were the participants truly blinded, or were the investigators truly blinded? And you could ask people to guess, guess which study you were in, and if more than, if people's guesses are better than you would expect by chance, you may find out that there was some way that it was easy for them to figure out which trial they were in. On the other hand, there are many examples of trials where people receiving placebos were convinced that they were receiving the treatment. So it kind of goes both ways there. We talk a lot about ascertainment in randomized controlled trials, and basically that means measuring important things along the way. How do we know the treatment was received? How do we know the outcome is the outcome we're interested in? And there's just a lot of process evaluation. Randomized trials are all about impact evaluation and measuring endpoints, but there's so much process evaluation that goes on along the way, and those of you who have worked as clinical research staff know this, to really figure out how is this intervention being delivered, who's in, who's out. Are people assigned to treatment getting the treatment and only the treatment? Are people assigned to control not getting the treatment? So that's a really important ascertainment question to see if there have been any unplanned crossovers. We also want to know that for people who are getting the intervention, it's being delivered as it was intended. So that's a fidelity question. If it's a counseling program and the participants are supposed to get an hour of counseling a week, is it really an hour, or does it turn out that's half an hour? Or if it's supposed to be with PhD trained counselors, is it actually master students? We want to know at the end, again, when we see a difference or we fail to see a difference between our treatment and control, that the intervention was really delivered as intended. Otherwise, our power analysis is really incorrect. And then similarly, to the extent there's any compliance that has to happen, are people taking the medication? It's one thing to dispense the medication or look at pharmacy records, but do we know that at home twice a day that patient is opening a pill box and taking a pill? And why is that important for compliance? Well, here's a trial that looked at placebo and propranolol drug for the impact on mortality. And they've divided within each of the treatment groups, with treatment and placebo, the good compliers and the poor compliers. So we see overall that the drug did a better job at reducing mortality than the placebo, but there's an even starker difference between the poor compliers and the good compliers in whose mortality was lower. So understanding compliance and understanding compliance, the relationship between compliance and your outcomes is critical, and will often determine this kind of stratified analysis that you might want to do. How do we enhance compliance if it's the kind of intervention where the respondents or participants in the study need to do something? We've talked about washout periods. You can also do run-in periods where the participant is assigned to treatment or control and they know about it, but there's about, maybe a couple of weeks when they're getting used to the intervention before you actually start the clock running on measuring outcomes. And it's a good way to identify non-compliers. Depending on your study design, if you've accounted for this ahead of time, you can actually remove them from the study. Obviously, frequent participant contact is important. Again, I'm guessing many of you have worked on studies where you're contacting participants a lot to see how the intervention is going, to see if they're complying. We have a whole center here at Penn looking at incentives and including incentives for participation in trials. And there's various technology now available to track certainly something like medication adherence. This slide refers to calendar packs. There are also little machines now that open and shut that can record the opening and shut times to see whether people are at least opening the medication box when they're supposed to be. Again, if you want to see the pill go down, you need a camera or something. And there's been research done on what reduces compliance with a trial or with any kind of treatment. The longer the study goes, the less likely people are to comply the whole time. If the intervention is very complex, there's often a drop-off in compliance. If it's a drug that's going to have side effects, of course, we might expect people just to bail on the study. Or if partway through the study, some newer, shinier, better toy comes along that has even a better promise of treatment, of success, someone in your trial may just bail on the trial to go try the new treatment. And then if the study is geographically limited, we are a very mobile population, and we talked about dynamic populations last week. Any kind of migration into or out of your study area may affect compliance as well. If you can build ahead of time, if you know your population is going to be highly mobile and you can build in the resources to do tracking, that's very effective because your ascertainment for endpoints is much better. And how do we assess compliance? We can ask people, which is okay. We can use biomedical markers. So this is often done for smoking cessation. We can actually get people's saliva or urine and see how recently they were smoking. The bogus pipeline is an interesting method. It's basically a false lie detector test. So you can ask people for self-reports and actually hook them up to a machine that they think is a polygraph, is a lie detector. And just the addition of that, the potential for their veracity being tested by this machine, they will often give you pretty good results. Pill counts we talked about. In community trials, when you're trying an intervention across a larger community, you can assess participation at the individual level and then aggregate that to a community measure. And you can be creative about how those observations are done. So if you're running a trial that's supposed to, for example, increase physical activity, you can go hang out at the park or the playground where you're hoping to see that and just do counts of people or frequencies or time spent. Those individuals aren't necessarily in your study. They're not particular participants, but you can get an aggregate individual measure that you can use to apply at the community level. Endpoints. So we talk about endpoints a lot, again, in randomized trials. And what are we talking about? We basically want to know, did the treatment cause something to happen? What is the outcome? It's basically another word for outcome at the end of the trial. And depending on what kind of endpoints we're interested in, if they're clinical or behavioral, we hope that they'll have very characteristic manifestations so that they're easy to recognize. If we have sort of a vague, generalized endpoint, we're going to have a lot of messy, noisy data. And as we've again spoken about for both case control and cohort studies where measurement of exposure and outcomes is important, we want to make sure that the study is using a very consistent definition and very consistent systems with a priori criteria. So the WHO World Women's Health Initiative trial that we've talked about, where stroke incidence was an important measurement, here's a very precise definition with a time component, with an imaging component, particularly a neurological deficit, that allows a clean, specific, and sensitive measurement of this endpoint of interest. As we've said, it's very nice if the people ascertaining endpoint are blinded to treatment status, so there's no possibility of bias there. And when we talk about complete ascertainment, that means we want to make sure that everyone who entered the trial can be measured at the end of the trial. We want to minimize any bias due to loss of follow-up. We would expect that people who leave the trial for whatever reason are probably different from the people who stay in the trial. And for that reason, making sure we can track people is very important. And then correct classification of the endpoint. Again, our assumptions about independence, our power calculations, and our sample size are based on being able to say you are in the treatment group, you are in the control group, and similarly you are in the outcome group of interest, you are not in the outcome group of interest. So if we're doing messy endpoint ascertainment, our results are going to be equally messy. So that's something to keep